Hello students, in the previous lectures we have discussed how to find the limit of function at a point, then connected that with the commutative function, then we have and then in the succeeding lectures we have connected the commutative with differentiability. Now in the first chapter of limits, while evaluating the limit or substituting the limiting value in the function, we got some forms and find it difficult there to find the limit. Now we will use hospital rule to find those forms of the forms of the type 0 by 0, infinity by infinity, infinity minus infinity, 0 into infinity, 0 is equal to 0, infinity by 0 and 1 to infinity. These seven forms are called indeterminate forms. These we obtain while find the limit. If we substitute the limiting value of the function in limiting value in the function, then we got such kind of forms. If such kind of forms are formed, then we can solve those. We can find those limits with the help of the L'Hospital rule, and these forms are called indeterminate forms. So first we'll take the first form, 0 by 0 form, 0 by 0 form, 0 by 0 indeterminate form, and we'll apply L'Hospital rule to find the limit in which we got the 0 by 0 form. So how to use the statement of the theorem? If f(x) and gx are two functions such that limit x, this is limiting value, limit x is to a of x is 0, limit x is to a of gx is 0. Both the limits are 0, then and second is both limit 0. So and first derivative of x and first derivative gx both exist, and first derivative of x is not equal to 0 in the dt neighbor of this point, limiting point. Then limit x is to a of f dash x upon g dash x exists, and this limit exists finitely or infinitely. Then limit x is to a of fx upon gx is equal to limit x is to a of fx of f dash upon g dash x. If it exists finitely, means this is the limiting value. If it does not exist finitely, means we'll proceed. We'll find the other function, second derivative of f and second derivative g both exist, and the second derivative g is not equal to 0 in the derivative of a, and the limit exists to a of second derivative of f upon second derivative g exists finitely. Then that will limit. If does not exist, then we'll proceed the same process. We go on this the limit x to a of fx of gx, then limit x to a of f dash differential numerator separately and upon differential numerator. If this again 0 0 form, then equal to limit x to a of f double dash x upon g double dash x, and so on till we got the finite limit. That's the use of the that this L'Hospital rule, and it will help us in finding the limit of function. Now note some important things we have to note down. If limit x approaches to a of f dash x upon g dash x, f dash x upon g dash x, g dash x are again take the form 0 0. As this is earlier, they take the 0 0 form. We repeat the process if this comes out to be, if this does not comes out to be finite. Because if this doesn't come to be finite, if this is a finite number, then this will be. So L'Hospital rule is applicable if a is replaced by minus infinity. If the limiting value is replaced by infinity or minus infinity, even then the L'Hospital rule is applicable. Before using L'Hospital rule, we have to apply standard formulas such like limit x to 0 of sin x upon x, limit 0 of tangent x upon x, both are equal to 1, and limit x to 0 of 1 plus x is equal 1 upon x is equal to e, limit x is to infinity of 1 plus 1 upon x is equal x is equal to e, etc. etc. Sometimes we will use some standard expansions to evaluate the limit of the form 0 by 0. Now, use of the standard expansion reduces the labor of differentiating time and energy. So, we have to remember these standard forms. We have to remember forms, and some we have derived in the earlier classes, and others we derive in the chapter of general theorem with the help of Machiavelli's form. So, actually, if x is there, so if the x is replaced by 1 plus x plus x squared by 2 plus x squared by 3 to 2 so 2. If sin x is there, we will replace it by x minus x cube by 3 to 2 plus x cubed by 5 factorial and so on 2. If cos x is there, we replace it by 1 plus 1 minus x cubed by 2 factorial plus x cubed 4 by 2 factorial plus 1 2. Tangent x is there, we replace it by x minus x cubed by 3 plus x 2x cubed by 5 by 5 is 1 or 2. If tangent inverse x is there, we replace that by x minus x cubed by 3 plus x of 5 by 5 and so on. If log of x 1 minus x plus x is there, x minus its extension will replace it by x minus x cubed by 2 plus x cubed by 3 minus x by 4 by 4 and so on to infinity. If log of 1 minus x is there, we replace by minus x cubed by 2 minus x cubed by 3 plus minus x cubed by 4 and so on to infinity. If 1 plus x is over and x is there, so we can place it by, we can use formula. If limit x to 0 is equal to e, or we can place it by we can place e minus ex by 2 plus 11 ex squared by 24 and so on. Okay, let us solve the first problem with the help of L rule, and it will make it will help us in finding solving the indeterminate form to a finite. Evaluate the limit x approaches to 0 of e square x minus minus x by sin x. So taking this given function, taking this function is equal to, we need to find limit x to 0 of sin x square x minus minus x over sin x. Now check, we have checked first, can we apply the L hospital rule? So replace the x by the limiting it, x 0 0, 1 minus 1 sin 0 0 form. So we can apply L hospital rule to this function fx upon gx. So this is equal to limit x to 0 of fx upon gx is equal to limit to 0 of f dash x upon g dash x. Differential numerator upon differential of denominator circle and so on. So the differential of e to x is equal to e to x, differential of e to minus is equal to minus e to x, this is plus, and d of sin is equal to cos x. Now again, at this time g dash x, put the limiting value. Put the limiting value here. Put the limiting value here. Limiting value here. We got 1 plus 1 upon 1 is equal to 10. Or we cannot solve it because sin x is there. We can use formula sin x upon x. We convert it to sin x. Second method to solve the same problem. Limit x is 0 of is for x minus 0 minus x upon sin x. So we'll divide sin x by x, numerator by x by denominator by x. So now this is one function, this is one function. So limit x to 0 of the quotient function, limit of the numerator upon the denominator. So numerator is equal to limit x to 0 of e square x minus e square x upon limit x to 0 of sin x. Limit sin x upon x is 0 is equal to how much is 1, substitute this value, and we are left with limit x to 0 of e square x minus we are left with e square x minus e square x minus e square minus x upon x. Now again put x to 0, 0, 1 minus 1 upon 0 by 0 form. Again we can apply L for the rule here. So this is f dash x on g dash is fx on gx again. So this is the differential numerator will be e square x. The denominator is equal to minus x. X is equal to 1. Now again put the limit x equal to 0. 0 is equal to 0. 1 plus 1 2 by 2. Now again second question is evaluate the limit x equals to 0 of 1 minus sin square x upon sin x square. Now we check, can we apply the L rule? Put x equal to 0. Or 0 1 minus 1 sin 0 0 0 by 0 form. So we can apply L hospital to this function fx upon gx. It is fx upon gx form, 0 0 form. Can apply L hospital rule. Therefore, limit x to 0 of fx upon gx is equal to x equals to 0 of f dash x upon gx. Differential of numerator 0 constant 0 minus 2 cos x e dx of cos x minus sin x minus 1 plus differential numerator sin x is equal to cos x square. This x is 2x. Cancel out the common factor and convert into some standard formula. This sin x divided by sin x upon x is equal to 1 and limit of this limit x is 0 of cos x upon cos x square into limit x is 0 of sin x upon x. So this is equal to 1, and limit x is 0 cos 0 1 and cos 0 1 1 upon 1 is equal to 1 limit. Or we can substitute, we can take the circular formula here. 1 minus x is equal to sin square x. So multiply denoted by x, denoted by x, multiply denoted by x. This is 0 is form. You can differentiate it or here also, or you can use formula here. Sin x upon you multiply this way. You multiply x divided by x. So sin x upon sin x x square. Sin x upon x limit whole square. X 0 of sin x upon x whole square upon x square upon sin of x square. So we can this way, or you can take this because it's zero form, you can straightway differentiate this also. This will be dx of sin x sin square x equal to 2 sin x cos x. Dx of sin x cos dx of sin x equal to sin x square equal to cos x 2x. You cancel. Now sin x square x is equal to, separate them. Sin x square x 1, cos x square x is equal to again this cos x upon cos x square is equal to limit x 0 cos x square x square limit x is 0 of sin x upon x is equal to 1. Yeah, it's called 0 into 1, 1 upon 1, 1 upon 2, 1, the same. Now evaluate the limit x is 0 of x minus sin x upon tangent cube x. Again, tangent cube x is here, tangent is here. So we will multiply the denoted by divide the denoted by x and denoted by x and x cube and multiply by x cube. So we got this equal to x minus sin x upon uh, x cube into tangent x upon tangent cube x upon x cube. So limit the quotient limit. So limit is taken inside the bracket. So then x is 0 of then x when x is equal to 1. So we are left with limit x equals 0 of x minus sin x upon x cube. The form. Now this is x is 0. 0 form. As we can apply L absolute here. Differentiation is this 1 x of sin x cos x minus 3x. Again put x equal to 0 cos 0 1 1 minus 1 0 0 form. Again we can apply L hospital rule here because this 0 0 form. Differentiate this with 2x. Again this is 1. Differentiate cos this 2x. 1 is 0. Cos x minus sin x minus the plus sin x upon x of 3x squared 6x. Again 0 0 form. Again apply differential rule till we get the definitive. Is equal to dx of sin cos x dx of 6x x is 0. Now evaluate the limit x is 0 of x approaching to 0 of e square x minus e minus s square minus 2 log of 1 plus x upon x sin x. Now this sin x is here. You can divide the numerator by x square, x by x. Sin x limit of this, limit of this. Separate limit x is 0 of sin x upon x is equal to 1. So we are left with this function. Limit x is 0 of e square x minus e square minus x minus 2 log of 1 plus x upon x square. Now put x equal to 0, 0. This is 0, 1 minus 1 minus 0. Log of 1 is 0. 0 by 0 form. So we can apply L here. Okay? So here 0 0 form. So this is the e square x e square x. E square minus x minus e square minus x. The dx of log of 1 is equal to minus 2 upon 1 plus x. Dx of 2x is equal to x square is 2x. Again put x equal to 0. 0 1 minus 1 is equal to 1. 2 1 plus 1 2 2 minus 2 upon 0 0 by 0 form. Again we can apply L to this. L this. This is equal to 2 minus 2. So this will become for x minus minus this will plus minus 1 by 1 plus x whole square upon 2. Now look at x is 0 1 minus 1 2 upon 1 whole square upon 2. So this 1 minus 1 1 minus 1 plus 2 upon 1 minus e upon 2 2 cancel, this is 1 cancel, 2 by 2 is equal to 1 is the